This is an introduction to molecular formula and empirical formula. We'll talk about what they are, what the differences are between them, and we'll learn how you write an empirical formula when you're given a molecular formula to start with. Here's a molecule of the compound ethene. Let's see how to write a molecular formula and an empirical formula for ethene. Now, I often like to think of molecular formula as the regular formula, which you may already be familiar with. The molecular formula tells us how many atoms of each element are in a compound. So ethene here has two elements, carbon and hydrogen. For carbon, it has 1, 2, 3, 4 atoms, so we do C4. And then for hydrogen, we've got 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. C4H8 tells us how many atoms and of what type are in this compound. Now, empirical formula over here is all about the ratio of different types of atoms in a compound. Okay? So here we have 4 carbons and 8 hydrogens. Let's write this as a fraction or as a ratio. Okay? So we got 4 carbon over 8 hydrogen. Now, what's special about the empirical formula is it tells us the simplest or most reduced ratio of the atoms in a compound. So if this ratio or fraction here were on your math homework, how would you write this in the simplest or most reduced form? Okay? You'd think, what was the largest number that you could divide both of these by? And in this case, it's 4. We can divide the top by 4, and we can divide the bottom by 4. And when we do that, we'll get 4 divided by 4 will give us 1 carbon over 8 divided by 4, which is 2 hydrogens. And this is now the simplest or most reduced form of this fraction or ratio. Now, we write the empirical formula based on this simplified ratio. Okay, so it's going to have 1 carbon, C, we don't write anything after it because it's just 1, and then H, 2 hydrogens, H2. So CH2 is the empirical formula that represents the simplest or most reduced ratio of the atoms in the compound, whereas a molecular formula tells us how many atoms of each element are in the compound. Let's look at another. Here's a molecule of the compound cyanuric triazide. I think this molecule has a really cool shape. It looks like something out of Star Trek or something. Okay, so for the molecular formula, how many atoms of each element do we have here in this compound? Okay, so we got carbon, and we have 1, 2, 3 of them, so C3. And then we got nitrogen, and we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, N12. That is our molecular formula, C3N12. Now, for the empirical formula, we want to take this first and write it as a ratio. Okay, so 3 carbons over 12 nitrogen. And we want to ask ourselves, how can we simplify this as much as possible? What's the biggest number that we can divide both of these by? In this case, the largest number is 3. We can divide both the top and the bottom by 3. And that will give us 1 carbon over 4 nitrogen is the most simplified ratio of elements for this compound. And now we write the empirical formula using this most simplified ratio. So we'll have C1, so we don't put anything after it, and then we have N4. So CN4 is the empirical formula here. Now, not every compound or molecule has only 2 elements here. So we can't always get an empirical formula by just simplifying a fraction. But even when we have a molecular compound that has more than 2 elements, the basic math steps we use are still totally the same. Check out this molecular formula that has carbon, hydrogen, and oxygen in it. We want to write an empirical formula for it. We can't really write this as a fraction like we did with the previous ones, but we'll look at these numbers, 5, 10, and 5, and ask what's the largest number that we can divide all 3 of them by. For C5H10O5, that number will be 5. We want to divide everything by 5. So for the empirical formula, we'll get C, 5 divided by 5 gives us 1, so we don't put anything after it. H, 10 divided by 5 gives us 2, so we'll do H2. And then O, 5 divided by 5 gives us 1 again, so we don't put anything after it here. So this is the empirical formula for this molecular formula. We just want to ask, what's the largest number that we can divide each of these subscripts by in the molecular formula to get the empirical formula? Now with some molecular formulas, you just can't simplify them anymore. For example, P3N5. Okay? There's no number that we can divide both of these by to simplify it further. The same is true for C5H12. There's nothing we can divide both 5 and 12 by. When this happens, we keep this in mind, that if the ratio of atoms in the molecular formula can't be simplified anymore, the empirical formula is the same as the molecular formula. So for P3N5, its empirical formula is P3N5. And for C5H12, its empirical formula is just C5H12. Don't get confused by this. Teachers and textbooks love to give you molecular formulas that you can't reduce anymore and then ask you what the empirical formula is. This freaks a lot of students out. Don't be freaked out by it. Just remember that if you can't simplify the molecular formula anymore, there's nothing wrong. It just means that the empirical formula is going to be exactly the same as a molecular formula. Now finally, I want to mention that many different compounds can all have the same empirical formula. Early in the video, we saw that the molecular formula C4H8 has CH2 as its empirical formula. But many other compounds also have CH2 as their empirical formula. C2H4, C3H6, C5H10, and C6H12 all have CH2 as their empirical formula. The empirical formula, as we've said, is all about the most simplified ratio of atoms in a compound. So whenever we have a molecular formula with just carbon and hydrogen, where we have twice as many hydrogens as carbons, C2H4, C3H6, the empirical formula will always be CH2. So many molecular formulas can have the same empirical formula. Keep that in mind. So now you've learned about the difference between molecular formula and empirical formula. The molecular formula tells us the total number of atoms of each element that are in a compound, and the empirical formula is the simplest or most reduced ratio of those atoms. We saw that some molecular formulas just can't be simplified anymore, so the empirical formulas are the same as the molecular formulas. And finally, we saw that many compounds with different molecular formulas can all have the same empirical formula. So now that you've learned this, you might want to go on to the writing empirical formula practice problems, or you might want to watch my video called "What's the Point of Empirical Formula?"